This is Devin. This will be the first YouTube video that I've created. This morning I decided that I needed to come up with a little charger or something to hold my batteries to be able to charge them with. These are a lithium-ion batteries. They're a flat battery, the prismatic battery in an aluminum case. They're very similar to the 18650 batteries that are very popular, and this technology batteries power everything from your toothbrush to Tesla cars. I have a Opus charger here that will charge these. One thing to note that's a little bit different about them, on the 18650s, the whole case is negative, and then just this little button on the top is your positive. With these, it's kind of the opposite. The whole case, the aluminum case itself, is positive, and up here is where your negative is. So you have to make sure to put these in the right way to use them with an Opus charger. They fit in there, they work. They use the same charging as the 18650s. They're nominal voltage of 3.7, and high charge would be 4.2. They generally, I think, are about in the 1900 milliamp range as far as capacity. Some of the ones that I've been checking they tend to be somewhere around 18 to 19 or just over 1900 when I've tested them using the Opus charger. So this is the finished battery holder that I created this morning. It's got little tabs here that you can use to either put a clip to, or you could solder leads to these little nickel strips that are here. And this is the battery packs that these come out of. They're a flat battery pack that you would then connect your laptop to. The easiest way to get these out is twist these back and forth, and you can hear it crackling and it breaks the seals, and then you can get inside. There's other videos on YouTube telling you how to break into these packs. Make sure to use gloves so you don't get cut on your fingers, and some of the other YouTubes will have some other safety things. You want to make sure that when you cut the wires and stuff off of there that are inside, that you only cut one at a time. Don't cut across two, because that's when you can get a short circuit. Okay, so the first thing to do is to make this little box, and that's going to hold our batteries. The one that I made here, the bottom plate is 2 1/16 inches by 1 3/4 inches. This end plate here is 2 15/16 inches by 1 inch. Then you have two of these little end plates here. They are 1 3/4 inches by 1 inch. And this little piece on the side here is 1 5/16, so that's just 1/16 short of 2 inches by 1 inch. And for those of you that use metric, the bottom piece is 52 millimeters by 43. This piece here is 75 millimeters by 25. These two pieces are 43 millimeters by 25 millimeters, and this end piece here is 50 millimeters by 25 millimeters. I would recommend that you cut these out and try a dry fit before you do any gluing or anything to make sure that they're cut to size. The plywood that I used here was 1/2 inch. It's actually just a tad under a 1/2 inch. And it's for metric people, that's a 12 millimeter thick plywood. If you have different width plywood or you just have some other scrap wood, you may just have to change a few of your measurements. Shouldn't be too difficult. The key thing is this bottom plate, getting that to the right size. Basically I just glued those up, and I have a pin nailer, pneumatic pin nailer, so I put glue on them, and then I just put a couple of pin nails just to hold it until the glue set. If you don't have that, you can just use a clamp. I would probably at that point then maybe put these 2 pieces on the end, clamp them, let it wait until at least 15 minutes or so until it sets, and then do these 2 here on it. And I would recommend using some type of just about any kind of wood glue will work, but I like this one here, and it's a fast set. For a small project like this, the fast set is nice because then you can continue working right away. You don't have to wait a long time for it to dry. Okay, so then you're also going to need a nickel strip. You can find these on the internet. It comes in generally in rolls. This here is it's 0.15 millimeter by 8 millimeter, and I've cut these strips here 2 inches. So basically you just want the strip to be able to go from the inside here and come out close to this edge here. So you need 2 of those. Then you'll need some, this is 3M 2-sided tape, double-sided tape, foam tape. Okay, the foam tape is needed so that you have compression so that you can keep the batteries tight in the holder. So you're going to want to take your foam tape, then you can do this before you cut it to length if you want, and you want to set I put a little mark there so I knew which side it was on. You want to set your nickel strip on there, and you can use either an X-Acto knife or a razor blade and just trim here. You're not trying to cut all the way through the foam tape, you're just trying to cut through this the piece here. You're just trying to cut through the top part here, not all the way through the foam. Okay, I was doing some editing this evening, and I don't like the way I showed cutting the tape. I was not actually cutting the tape at that time. I had already pre-cut it, and I was just kind of demonstrating it, but I didn't want to give people the misimpression that was a good way to cut it, because it's probably actually a good way to cut your finger. So here's how I recommend cutting the tape. Is you take and cut your piece off of the roll. Get a piece of your scrap plywood from when you were making your device. Put some wax paper on top of that, and put your strip down on the wax paper. It kind of gives you a way to hold it in place. Take your nickel strip, line it up on there. Now you can take your blade or your X-Acto knife. Again, you're not trying to cut completely through it, you're just trying to cut through that top layer. Now you can peel it off, and with it being on the wax paper, it will still be good to use. So then you take this, and the edge that you've marked where you've cut it, take and put that in your holder. Press it in firm, and the extra part, just let it overlap. And do the same thing with your second piece. And you want to take that little strip off that you cut. And I just leave the rest of it on there because it allows you to get the batteries in a little bit smoother. So then you're going to take your little piece of nickel strip, drop it in through the little slot that you have here, and just press it up against the double stick tape. One other safety item that you should know about. Let's take these batteries out of here. So you've got a nickel strip across there and your nickel strip down here. So when you put these batteries in, this is putting the batteries in parallel. You want to make sure that your batteries have approximately the same voltage, that they're close in the same voltage. Because otherwise, when you put those two batteries together, if this battery here were a lot higher in voltage and this one were low, what would happen is you'd have a large rush of current from this battery into the other one to even them out, and it could heat up your nickel. It could cause problems within the battery, and it would reduce, if it didn't actually ruin the battery, it would at least possibly make it so its capacity is not as good, as its lifetime is not going to be as long. It will do some internal damage to it. So just make sure that they're close to the same. A lot of times what I'll do is I'll take and I'll measure the batteries, and then I'll take and line them up with the lowest battery here to there. And as long as they're relatively close, I'll put the one that's got the lowest voltage in, put the next one in, and then I'll just give them a minute or so. A lot of times it doesn't even take that long, but for the batteries to equalize in voltage. So now what happens is when you put this next one in, if it's higher in voltage, the difference isn't as much between this one and this one what it would have been normally, and it's got two batteries to run that into, so your current draw isn't quite as much. Give that time to settle, and then put your last one in, and then they'll equalize, and they should eventually come to the same voltage. One other thing you want to absolutely make sure that when you're putting these batteries in, make sure that you're putting all the positives on one side and all the negatives on the other side. If you were to flip it and put it in backwards, that is going to cause basically a short circuit between them, and they will get hot very fast. If you do that by accident, you want to pull them out right away, because at that point they could get so hot that they'd go into runaway and could actually, it would be possible for them to start a fire. These batteries do have safety mechanisms in them, so that if the pressure builds up too much from the heat, that they, in many cases, they will protect themselves and shut off. You basically killed the battery at that point. But I wouldn't trust that. Just don't do it. If you do it by accident, pull it out immediately. And as you put them in, just put your thumb or something on there and feel them. And if all of a sudden you start feeling heat, there's something wrong, pull those batteries out. Either you got a bad battery or you put one in backwards. Just a little safety hint, tip there to protect yourself. Okay, one thing that you can do once you get this put together, and you want to make sure that you are making good connections to your nickel strips on all the batteries, is you can come in here and put your lead on the copper, on the nickel strip, and then use the other lead and test each battery. And you should see voltage coming through each battery. So that lets you know that these connections are good on this side. Then do the opposite for the other side. And then that way you know that your connections from the battery to this side of the nickel strip are good. So you know that you've got good connections there. So one thing that I might do different is to take and make it longer so I can put 8 of these in at one time. The other thing that I might do is to take and, instead of having so that both nickel strips come out the same side, I would maybe make it so that one came out this side and one came out that side. It just allows for a more even flow through the batteries because everything's flowing. It's got the same distance to get from this pin to the one down here. Doesn't matter which battery it goes through, it's the same distance. Whereas with this setup here, if it comes in here through there, each battery coming out this way has got just a little bit more resistance for that current to move up and through there. Well, I hope that this helps you. If nothing else, gives you some ideas for other projects you have. If you like this video, go ahead and like it, and have a good day. Thank you.